In this video, we're going to go over how to solve rational inequalities algebraically. And we're going to start off with a problem from MyMathLab. And you might actually get lucky enough that this is the exact problem that you get as well. Hopefully not, but if it happens, congratulations. So I like to start off with this problem because it walks you through all of the information you need. So consider the rational inequality at x minus 3 over x plus 4 is greater than 0. After setting the numerator and the denominator of x minus 3 over x plus 4 equal to 0, the equations x equals 3 and x minus 4 are obtained. And so we have those 2 points on the graph. Now, before we go on, let's just kind of, what are we doing here? It says after setting the numerator and the denominator equal to 0. So when I take the numerator and I set this equal to 0, I get x equals 3. What does the top of these tell me? Because we do need to know the difference. This here tells me my 0, my x-intercept. Okay, so then when I take the bottom, x plus 4 equals 0, and I subtract that 4 over, I get x equals negative 4. And this is my vertical asymptote. So I see my vertical asymptote here, and that's where it came from. So after setting the numerator and the denominator equal to 0, we got these two equations. Now, when you make these number lines, my suggestion is to make some dashed lines through your vertical asymptote, because remember from last video, vertical asymptotes never get brackets because we're approaching it, but we are never reaching that number. Okay. So I'm going to put a point, but I'm going to represent the vertical asymptote with a dashed line. So then it goes on to say, these values are shown as points on the number line below. Also, x minus 3 over x plus 4 is positive at negative 6 and 5. So they have picked a test point of negative 6 and 5. And they found that then in this interval here, my graph is positive, and they have found in this interval here that my graph is also positive. And it also found negative at 0. So this is another test point. And they found that interval to be negative. Based on this information, find the solution set of x minus 3 over x plus 4 is greater than or equal to 0. So we are talking about this portion here, not including that negative 4 because of that vertical asymptote. And this portion here, notice including that 3, that 0, that point. So this will be negative infinity to negative 4 with parentheses because of that vertical asymptote there. Connect these two portions by the union, and then 3 to negative or to positive infinity. This here is a point, so it does get a bracket. So here's my answer. Now they did all of the work for us. We had to read it, digest it, apply it. But this is what we have to do. For example, 5, when we're solving the following inequalities algebraically. You have to set the numerator and the denominator equal to 0. I sound so funny, guys. I'm so sorry. I'm like so stopped up, but okay. Set the numerator and the denominator equal to 0, so you can find the 0 where it's crossing the x-axis and your vertical asymptotes. And then pick your test values in those intervals and figure out positive, negative, positive, or I guess just positive and negative. And then answer the inequality. Okay. So Let's first find our zeros. We find our zeros by setting the top, in this case, x minus 1 equal to 0. We'll subtract that over and get x equals 1. So we have a 0 at the ordered pair of 1, 0. I also need vertical asymptotes. You do that by getting the bottom and setting it equal to 0. We'll subtract that over, and we have a vertical asymptote at the equation x equals -8. Okay, so let's make our number line. We have a 0 right here at 1, and we have a vertical asymptote at -8. So I'm going to represent that with some dashed lines so I know what this is. Okay, so now we need some test points. If I make a test point of -9, when I plug that in, I'm going to plug that into everywhere I see an x. So this is -9 minus 1 over -9 plus 8. Negative minus negative is the negative, specifically -10. Negative plus or -9 plus 8 is a -1. Negative over negative is positive. And so what I care about is that this is a positive right here. We need another test point. If I pick a test point somewhere in the middle here, 0 is always kind. We'll go with 0, so I'm going to plug in a 0 in both of these. So we have 0 minus 1 over 0 plus 8. That's -1 over 8, which is -1/8. So negative there. And then we need a test point over here. Let's just go to 2. So we have 2 minus 1 over 2 plus 8. So we get 1 over 10. So this is positive. So we'll come back up to the original problem, and it's wanting to know, when is this rational function less than 0? So that is this part right here in the middle. So my answer is -8 to 1. Exact same thing here on B. We start off by finding our zeros. And you find your zeros by taking the top and setting it equal to 0. Well, this one tells me that x equals 4, so that's my ordered pair of 4, 0. And this one here tells me that x equals -9, which is -9, 0. Now I need my vertical asymptote. You take the bottom and you set it equal to 0. There's nothing to do there. That's my vertical asymptote. So we'll make our number line. I have -9. I have 0 with a vertical asymptote. And I have 4. So we need some test points. You should have a lot more room on yours. I don't have as much on mine, but that's okay. I've got test points at -10. Let's go -1, 1, and 5. So plug those in to those equations. And when you plug this in, you have to do parentheses around that whole thing there. So let them know that that's the top of the equation. So if I'm plugging in -10, parentheses that I'm adding, then parentheses right here, we'll have -10 minus 4. Close your parentheses, open 10, -10, plus 9. Close this parenthesis, close the parenthesis that we started with, divided by -10. So we get negative. Once you have that plugged in, now you just come up here and edit. This is -1. So positive. Then this changes to +1. Negative, and then lastly, 5. These have been going plus minus, or alternating the other way. The other one was plus minus plus. Don't assume it's going to alternate because they don't always alternate. You've got to pick your test points and plug them in. Once we figure out our plus and minuses, we'll come back up here. This is when it is less than or equal to 0. So that is this portion. And that is this portion here, not including that 0 because it's an asymptote. So we will have -infinity to -9 with a bracket. The union to put these two together, and then we will have parentheses 0 to 4 with a bracket. Now, I don't think this is that bad, but you can also, just like before in the first video, put this into your calculator. When you put it in, you've got to put it in with parentheses, the ones that we added. You've got to, I don't know what I'm trying to say, you've got to signal to your calculator that this is all in the top. If you put this in as x minus 4 parentheses x plus 9 parentheses divide by x. It is just taking this portion here and only dividing x plus 9 divided by x. You've got to let your calculator know, I want to divide all of this by x. And I think I might have messed something up. Because now that equals, okay, there we go. Okay, so double parentheses, because you're letting them know that whole portion is on the top. Okay, so I'm going to graph it. I think I'm going to graph it. Window zoom. Okay, well, I did something to mess up my calculator. Go figure. So I'm going to go search for somebody to help me out with how to graph some things now. Maybe this was supposed to be highlighted. Is that supposed to be highlighted? Ah, okay. I guess I only thought I highlighted my equal sign, but I didn't. It's supposed to be. So, okay. So you can see here, if you put this in your calculator, I do know where these two zeros are because I solved them, right? I know that's my -9. I know that's my +4. It's nice to be able to solve for these so you can know exactly where it's crossing. It does not show you your vertical asymptotes, so you have to be able to know that you have one going on right here. And so when you're solving for less than or equal to, you can see it's just this portion right here. And it's just this portion right here, knowing that this is going to get closer and closer to that vertical asymptote. So you can use your graph as well if you don't want to do the test points.